Welcome guys to today's class on practical physics. In this video, we want to discuss how to perform experiments on compound pendulum. Yes, we want to see how to do that without touching apparatus. Yes, in exam hall, in your practical lecture room, you will learn how to use your equipment and do the experiment. So this video will concentrate on how to do the practical, how to do the experiment without touching apparatus. Now, before we commence into the experiment fully, we want to recall ourselves what compound pendulum simply means. Compound pendulum is a pendulum or any swinging rigid body that is free to rotate about a fixed horizontal axis. Yes, the rigid body can be called a definite shaped body. So in this case, the definite shaped body we want to use is a uniform meter rule. A uniform meter rule. A uniform meter rule is a ruler that has a calibration between 0 to 100 centimeters. That is 1 meter rule. Yes. Now, in this experiment, if you are performing it in the exam hall, you have to use G-clamp, dex, and meter rule and do the experiment. Now, because you are not performing it live and direct, we want to use formula method to do that. Look at the typical formula for this experiment. Period equal to 2 pi root K square plus H square over GH. That tells you that in experiment for compound pendulum, this K means radius of gyration. Radius of gyration of a uniform meter rule from the center. Now, this K that is called the radius of gyration, G, acceleration due to gravity, this is the what? Length. The length you clamp the G clamp, or you fix your G clamp, that is from 0 to 10. It means you clamp it at 10. If it's 15, 0 to 15 at 0.15. So this is the individual length you clamp the meter rule. Now this CG is center of gravity. For a uniform meter rule, center of gravity is always at 50 cm. Okay. Now this is the total length of the meter rule. Because for meter rule, that is 100 centimeter rule. Now, from this formula for this compound pendulum, it sends a message to us that compound pendulum experiment is simply experiment that helps you to determine the value of 1, radius of gyration, the value of 2, acceleration due to gravity, and the value of 3, moment of inertia of that uniform meter rule from the center. Okay, so we can get radius of gyration, we can get acceleration due to gravity, we can get moment of inertia as well of that uniform meter rule. That is what this experiment will help us. And when we see how to get our table, plot our graph, after plotting our graph, we will now see how to confirm the answer for G, answer for K, and all have you. Now, for you to do this, because we want to use formula method, you will have to note that G, acceleration due to gravity, is always constant. It's approximately 9.8 meter per second squared. So everybody cannot get this value, and so it will have a range. The range is 9.54 to 10.02 meter per second squared. That is the range of acceleration due to gravity. That means your answer can fall between this range. And when it falls between this range, it means your experiment is okay. Yes. Now look at our table. Someone can say, let him use this H as it is in centimeter and run this table. But I would advise you, if you are performing this experiment, ensure that your units is always in SI units form. That means here should be H meter. 10 to meter means 10 over 100, 0.10, 0.15, 0.20, 0.25, 0.30. That means I've been able to convert this to meter. That is the SI unit. Now it is this a meter form that I'm to use here to make sure that my table is in SI unit form. Now, it is important for us to note that when we are looking for formula for radius of gyration, of a uniform meter rule from the center of gravity. That means we say the K is equal to L all over root 12. We have been able to know the formula for our radius of gyration, that is K, to be L over root 12. If you watch my video on rotational dynamics of rigid body, let me just give you a hint of what we did there. We will notice that moment of inertia of a uniform meter rule from the center is equal to ml squared all over 12. You will see how everything was derived. Then the radius of gyration of any rigid shaped body is known to be square root of I over m, where I is the moment of inertia and m is a mass. So what is the moment of inertia here? We say square root of ml squared all over 12m. This will cancel this. Square root of L squared L. Square root of 12, square root of 12. That is how we got it. So feel free to watch the video on rotational dynamics of rigid body on my channel. Just type Chidos Daniel rotational dynamics of rigid body and you enjoy the video on that, so that you see how you learn many more formulas for moment of inertia of any definite shaped body. Now we can now sort out the value of K, knowing our L to be 100 centimeter all over square root of 12. You use your calculator. 100 divided by square root of 12, you will be having 28.9 cm approximately. Now make it to be in watts, a meter. Changing this to be a meter will be approximately 0.29 meter, because we want our table to be in a uniform SI unit. Now I will come here and put 0.29 meter. That is the value of K I am to use. Okay, now we pick any value for G from this range. I can pick 9.6 meter per second square. Why? I just decide to pick it. You can pick any one you want, but why I pick this is, by the time approximations are made in the table will be done, at least if you increase the G, the increments will still be in this range, because I'm using a 2 decimal. I make sure that my decimal place is in uniform. Now to get the first value, I carry my K, put here, carry my H, which is 0.1, put here, carry my G, put, carry my H, put, and get the first value of T. First value of T will be equals to 2 pi root 0.29 squared plus H 0.10 squared, that is the first value, all over G 9.6 times H 0.10. That will be giving me, I'll press it in calculator, 2 shift pi, then times square root bracket 0.29 squared plus 0.10 squared divided by bracket 9.6 times 0.10. That will be giving me 1.97 approximately second. So I'll come here and put it under period 1.97. It has the unit on the top. Then I'll do same for the second one. I will now say 2 pi root K is constant 0.29 square plus 0.15 squared all over 9.6 times 0.15. So what I will be having is, I'll be having 1.71 seconds. Right, 1.71. I'll come again, clean everything, do for the third one. I will now say 0.29 square plus 0.20 because I'm in the third column, square all over 9.6 times 0.2. Let's see what it will give us. 1.60 seconds. So I'll write 1.60 seconds. So we'll get the next one by saying t equals to 2 pi root 0.29 square plus 0.25 squared all over 9.6 times 0.25. We'll put it in brackets. So this will be giving you approximately 1.55. Now we come again. We do the last one, 0.29 square plus 0.30 square all over 9.6 times 0.30. So this will be giving us 1.54 in 2 decimal places. Now it is important to know that period simply means time taken to complete one oscillation. Time taken to complete one oscillation, and it's put mathematically as T over N, where N is 20 oscillations, that is number of oscillations, 20 oscillations. And so we can get the value here by saying 1.9 equals to T all over 20. Therefore, T will be equals to 1.97 times 20. I will now say 1.97 times 20, 39.4. 39.4 seconds. Then I'll come to the next one. The next one will be 1.79 times 20 again. 1.71 times 20, 34.2. 1.6 times 20, 32.00. Then 1.55 times 20, 31.00. 1.54 times 20, 30.8. So we got all these values by saying the T we have times 20. That 20 is constant because that is 20 oscillations we perform. Now to get this value T square, we say 1.97 square, 3.88. Then 1.71 squared, 2.92. 1.6 squared, 2.56. 1.55 squared, 2.40. 1.54 squared, 2.37. We have gotten our T squared. Okay, So next thing we'll do is we get our ht. Ht means h times t. H times t here. 0.1 times 1.97. 0.197. So 0.15 times 1.71. 0.26. This one to two decimal places will be 0.2. Then 0.2 times 1.6. 0.32. 0.25 times 1.55. 0.39. 0.30 times 2. 0.30 times 1.54. 0.46. We have succeeded to get our table of values. Yes, without touching apparatus. That just means using formula method. In the next video, we will see how to plot this graph and answer questions that will follow it. Thanks for watching the video.